Today we're going to talk about what linear means and how to tell if something is linear. So just as kind of an intro thing, if we solve this equation, notice there's one variable and that's x. We would add 4, so we get 3x equals 12, and then we would divide by 3 on both sides and we get x equals 4. So 4 is the only solution. So this has one solution in it because it has one variable. However, if we do this problem and I ask, okay, solve that, you're going to kind of be puzzled. Like, well, I don't know how because there's 2 different variables in it. So I have to give you some limits here. So what we're going to do is we're going to solve it if x were to equal 0, if x were to equal 1, and if x were to equal -1. So we'll just do 3 different problems and see what kind of answers we get. So to solve it, that means you have to substitute 0 for x. So it'd be 2 times 0. And you have to solve for y then. So if I do 2 times 0, that just is 0, so we can ignore that. 3 times 2 makes 6, so y equals 2. If I were to plug in 1 for x, I'm going to do 2 times 1 plus 3y equals 6. This is going to make 2. I subtract 2 to the other side. I get 3y equals 4. So y is going to be 1 1/3. So y equals 1 1/3. And then we'll do the last one real quick. We'll do 2 times -1 plus 3y equals 6. We're going to get -2, which means we have to add it to this side. So I get 3y equals 8. If I divide by 3 on both sides, it's another mixed number, but it's going to be 2 2/3. So we have 2 2/3. So what we're going to do is we're going to graph these pairs, 0, 2, and etc. And we're going to see what kind of shape we get. So 0, 2 would be here. 1, and then 1 1/3. That means you definitely go up a whole space, but only a third of a space after that. So it's going to be really close to 1. And then we have -1. You're going to go up 2, and you're going to go up 2/3 of a space, which is just more than half a space. So if I were to connect these, you always want to connect your dots if you have an equation. That line means it goes on forever. And we have to ask ourselves a question, how many solutions does this equation have? So in other words, how many things could you plug in for x? And the answer is infinite. There's infinite solutions. So in order to show that there's infinite solutions, we have to draw a line with arrows. That means, hey, our ordered pair is going forever. So if you would have picked a couple different ordered pairs, plugged something different in for x, you would have gotten points different than mine, but they all would have been on this line. So they could have been here, 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 whatever. But we're going to get the same line, no matter what we do. So then it asks, is it a function? And you should notice that it does pass the vertical line test. So yes, and I would just say because it passes the vertical line test. So what we're going to do is we're going to learn some tricks to tell ahead of time if something is linear or not linear. Now, linear makes a line, and that's pretty easy to remember because the word line is inside the word linear. So linear actually means line. So the rule says, first off, a linear equation is the equation of a line. And now there's 3 forms that you can use to write an equation. So before, I actually gave you the equation. I gave you this linear equation and you had to graph it. We will be going backwards where I give you the graph and you come up with the equation. And there's 3 formulas that you can present your answers. The first one is standard. That one is not so popular. We don't use that a lot. The next one is point slope. And then the one we'll focus on the most is is slope intercept, which is y equals mx plus b. So this is the one that will be most important. We'll use this far more than anything else we use. But you can technically, if it just says write a linear equation, you can write it in any of these three forms and it'll be okay. So in order to know this little cheat, so you can know ahead of time if your graph should make a line, is 3 rules. You can't have exponents greater than 1. So if it has an x squared in it, it's definitely not linear. You can only have 1 or 2 different letters. So you can't have y, x, and z. You can't have 3 letters. You can only have 2 at the most. 1 is okay, but you can't have more than 2. And then variables cannot be in the bottom of a fraction. So it's okay to have 1/2 x, but it's not okay to have 1/2x. That would be bad because x is in the bottom. And if the variable's in the bottom, it's not a linear equation. So in these examples, you're just going through and deciding if it's linear. So you're checking the 3 rules. So I see no exponents, only 2 letters, and they're both not in the bottom. So yes, it follows all 3 rules. Example number 2, check them quick, but yes, it does. Number 3 just has 1 letter, and that's okay. Number 4 has a fraction, but y isn't in the bottom, so it's okay to have fractions. You just don't want the letter to be in the bottom. Same thing with the next one. You have a fraction with a letter, but the letter is not in the bottom, so we're okay. And then the last one, we see an x squared, and right off the bat, that means no. The next thing we'll talk about are intercepts. So if you don't remember, an intercept is basically where an axis or where a line crosses an axis. So you have an x-axis and a y-axis. So anytime you have a line that crosses, that is the intercept. So this would be the y-intercept because it's on the y-axis. This is the x-intercept because it's on the x-axis. Most word problems that you have to work out, especially in Algebra 2, basically, like when you find an answer, you're actually looking for the y or the x-intercept. The reason I wrote that most lines have 2 intercepts, an x and a y, is because we can't forget about lines that look like this. So vertical lines, they only have an x-intercept, so they'll never cross the y-axis. The only time they do is if it's actually on the y-axis itself, and that doesn't happen a lot. And lines that are horizontal, of course. So the lines that are horizontal typically only have a y-intercept instead of an x-intercept. So we just don't want to forget about those because we will eventually be covering that. So we're going to start with x-intercept. Obviously, it's where it crosses the x-axis. However, we do have another word for x-intercept, and it's called finding the zero. So example would be the zero of a graph. That is also called the x-intercept. Now that doesn't mean like 0, 0 or the origin. It just means 0 in a different context. So if I were to say, where's the 0 on the graph? The 0 means x-intercept. So it's just something you have to read differently based on the situation. And then this one's really important. The y value of an x-intercept is 0. So that means that you use 0 for y. So if it's an x, you use 0 for y. And if it's the opposite, if it's a y-intercept, obviously you're going to switch them. So y-intercept is where it crosses the y-axis. The x value this time is 0. So it's almost like you put 0 in for the opposite letter. Y-intercepts are usually referred to as beginning values. So if I say that Ashley started the day with $20 and she spent $1 per hour, 20 would be the y-intercept because that's the beginning of the story. So the beginning is the y-intercept. And that's why y-intercepts are definitely more important for our purposes than x-intercepts. Because everything that we do, every problem is going to have a beginning. And the reason it's the beginning is it's because when x equals 0. So you have to think if you're graphing time versus age, the very beginning is time 0. So whatever the y value is, that's what you start out as. So some examples of x and y intercepts would be, remember y has to be 0, but x can be anything. So it could be 4, 0. It could be a fraction, 0. It could be a negative number, 0. It could also be 0, 0. That's okay. But notice 0 is in the second spot for all of our intercepts. With the y-intercepts, it's just going to be reversed. So 0 is going to be in the x spot, and whatever you get for y is going to be in the y spot. So it's basically like reversing all of the ordered pairs that you see above. So these are all y-intercepts, and notice 0 is in the front of those. So it's really important that when you spot an intercept, you have the number 0 in the correct place, but you have to have a 0. So what we're going to do is we're going to estimate the y-intercept. We're not going to do the green-yellow thing. We're just going to circle them and label them. It's a little quicker. So make sure you don't just circle anywhere you see dots. So this dot right here is not an intercept. That doesn't cross an axis. This is an intercept. And then this is an intercept. So we're going to do the x-intercept first. I just like to label x above it. And then the y-intercept, I'm just going to label a y by it. That way you don't mix them up because it's easy to do that. So what I want you to do is I want you to go through each of these and just circle and label the x and y-intercepts for now, and then we'll do ordered pairs later. So hopefully your answers match up with mine. You want to make sure you have the correct letters for these. And on letter F, the x and y-intercept are both in the same spot. So I just write x comma y for that. So what we're going to do is we're just going to write the ordered pairs. Now some of these lines aren't exactly like perfect, so we might have to estimate, and that's okay. We'll just do the best we can. So the x-intercept looks like it's at 3, 0. So that means that the 0 of the graph is also 3, 0. Our y-intercept, however, is at 0, -3. So the next one looks like our x-intercept is at 2, 0, which means that the 0 of the graph is 2, 0. Because remember, x-intercept and 0 are the same thing. And then the y-intercept is 0, -2. So what I want you to do is go through and just as closely as you can estimate, just estimate the x and y-intercept, and then we'll compare answers. All right, so check your answers with mine. The only ones that you have to be really careful about was letter E. On your notes, it is definitely not at -1 or -2. It's in between. So I estimated -1.5. So again, when you're estimating, you have to do the best you can, but you want to try to be as close as you can as well. The last part we'll do in a separate video. This video is, I think, long enough. So in class, we didn't get to this that day, so we'll just finish this up